With factoring trinomials by grouping, and that's what we're going to do here, we're going to take the trinomial, and basically factoring by grouping required us to put these things into groups of 2 using parentheses. So when you think about a trinomial, I've got 3 terms here. Well, that's no good for factoring by grouping, so I have to transform this thing a little bit so that factoring by grouping works, so that I can put things in groups of 2. All right, so here's what we do. We build a bridge, and that's not really a technical term. That's just an easy way to remember this. What we do is we take the first coefficient and the last coefficient, and we multiply them, okay? So we multiply the first and the last coefficients, okay? And that's what I mean by build a bridge. Take the first term and the last term, essentially, and multiply them. Because we just look at the coefficients, all right? Then we're going to find 2 numbers that multiply together to give us the number that we got from the bridge, okay? So the number from step 1, but add together to give us the middle coefficient. And really, we're just trying to get so in these 2 steps, we're getting all 3 terms kind of involved. We do first coefficient times last coefficient, which gives us the bridge. So we need 2 numbers that multiply together to give us that, but add together to give us the middle coefficient. So now we're using all 3, all right? After we come up with those 2 magic numbers that multiply to the bridge but add to the middle coefficient, we're going to rewrite the middle term using those values as coefficients, okay? So basically what I'm going to do is I'm going to take this trinomial, I'm going to come up with these 2 values, and I'm going to split the middle term into 2 separate terms. And you see the effect that has when I look at these first 3 steps is basically I go from 3 terms to 4 terms, okay? So instead of having a trinomial, I rewrite that middle term as 2 separate terms. Now I have 4 terms, which allows me to do factoring by grouping. Once I have 4 terms, I can put them in groups of 2, all right? So I build a bridge, first coefficient times the last coefficient. I come up with 2 numbers that multiply together to give me the bridge, but add to the middle coefficient. And then I rewrite the middle term as 2 separate terms, okay? So now I have 4 total terms. I can do factoring by grouping, all right? So here's what this looks like. If I look at something like this guy, again, build a bridge, I'm going to take the first coefficient and the last coefficient, so the 2 times a -6, which is a -12. And now I just need to come up with 2 numbers that multiply together to give me that bridge, the -12, but add together to give me this middle coefficient right here, which is a +1, okay? And so the 2 numbers that multiply to a -12 but add to a +1 are a 4 and a -3, all right? So now here's what I do. I'm going to split up this middle term. Instead of having this as a 1x, I'm going to rewrite it as a 4x and a -3x, because that's the same thing, all right? So I'm just going to split up that middle term into 2 separate terms. That x is now going to be a 4x and a -3x. And everything else just kind of tags along for the ride. So essentially, I'm just rewriting this trinomial, but I'm rewriting the middle term as 2 separate terms, okay? And now we see the effect that has. Now I can do factor by grouping. Now I can put them in groups of 2. So I group these 2 together, I group these 2 together. Out of the first group, I can factor out a 2x, which leaves me with an x plus 2. Out of the second group, I can factor out a -3, which leaves me with an x plus 2. And now I see these 2 polynomials that we have in common. So my 2 factors are the x plus 2. And then when I factor that out, I'm left with a 2x minus 3, all right? And again, this is literally the reverse of our distributive property with binomials, okay? When we multiply out these 2 binomials, I would distribute each piece, then I would combine like terms, the 4x and -3x, and bring us back to the 2x squared plus x minus 6, all right? So I build a bridge, I split up the middle term, I factor by grouping. If I do the same thing with the next one, again, I build a bridge. 4 times 5 is a 20, positive 20. And 2 numbers that multiply to a positive 20 but add to a positive 12 are going to be a 10 and a 2. So now I split up the middle term, so I rewrite this as a 4x squared plus 10x plus 2x plus 5. Okay, so it's the same thing, I'm just rewriting the middle term as 2 separate terms so that I can group these. So I do factoring by grouping. I group the first 2 together, and out of that I can take out a 2x, which is going to leave me with a 2x plus 5. Out of the second group, remember with factoring by grouping, we have to factor something out, and the only thing I can factor out here is a positive 1, which doesn't change anything, leaves me with a 2x plus 5. But it does allow me to see these 2 factors. See, now I have this guy in common. So one of my factors is the 2x plus 5. The other factor is what would be left when I take that away, which is the 2x and the plus 1. All right, so again, I build a bridge, I split up the middle term, I factor by grouping. Same thing with the next one. Again, I build a bridge. That gives me a -12. 2 numbers that multiply to a -12, but add to a positive 11. Well, that's going to be, let's see, that's a 3x squared oh, sorry, I forgot to write the terms down. That's a 12 and a negative 1. So I'm going to write that as a plus 12x and a minus 1x minus 4. And now I can do my factoring by grouping. So I group the first two terms together. I group the second two terms together. Out of the first two terms, I can factor out a 3x. Let me change back to blue here. So I factor out a 3x. That leaves me with an x plus 4. Out of the second two terms, I have to factor something out. This time it's going to be a negative 1. And now from here, I can see the two polynomials that they have in common. So one of my factors is the x plus 4. The other factor is what I would be left with, which is the 3x minus 1. Okay? So again, build a bridge, split up the middle term, factor by grouping. And now this next one, I could build a bridge and split up the middle term and factor by grouping, and that would be fine. It'll work out okay. But notice here that I have a greatest common factor of 2 with each of these. So I'm actually going to factor out the greatest common factor first because it makes things just a little bit easier in the long run. So I'm going to factor the 2 out. That leaves me with an x squared plus 2x minus 8. And the reason we want to get in the habit of doing this, because we'll have some shortcuts that we can do later. Inside here, I build a bridge. The two numbers are going to be a positive 4 and a negative 2. So I split up the middle term. Again, this 2 is just going to kind of tag along for the ride. So I'm going to rewrite this as a 2x squared plus 4x minus 2x minus 8. And now I can do my factoring by grouping. So I group the first two terms together. I group the second two terms together. Out of the first two terms, I can factor out an x, which leaves me with an x plus 4. Out of the second two terms, I can factor out a negative 2, which leaves me with an x plus 4. So now I can kind of see my two factors in the parentheses here. My two factors in the parentheses are going to be the x plus 4 and the x minus 2. But then this 2 that's kind of been tagging along for the ride just keeps on tagging along for the ride. And that's it. All right. If we build a bridge from the start, split up the middle term and factor by grouping, we'll get the same thing, except we'll end up with that 2 stuck in one of our binomials, and we'll have to finish factoring. So always look for greatest common factor at the beginning of the problem, and then always check for it again at the end of the problem. Okay?